Welcome to our podcast. My name is Sadia Anwar, Acquisition Editor at River Publishers. Today we are excited to have Dr. Jacopo Iannacci with us, a researcher at the Center of Sensors and Devices of Fondazione Bruno Kessler in Trento, Italy. He is also an author of a book with name A Fresh Concept of Software Resemblant Hardware to Leap to 6G and Future Networks, which will be the core part of our today's discussion. Thank you, Dr. Iannacci, for joining us.
Thank you for inviting me.
Let's begin with our first question. Dr. Iannacci, in your book, what inspired the new approach to hardware for 6G and how does it differ from the current paradigms?
Okay, thank you for the question. I want to spend just a few words about what was before the idea of this book, because I've been involved in research on MEMS technology, so on microsystems, and in particular on microsystems for radio frequency applications since a long time, since about 20 years. And I had the chance to see many hypes, many ups and downs in expectations, market expectation for these technologies. And this was somehow attracting my attention because I think that what makes it different is the approach to a technology. So not just from the point of view of which performance can be achieved, but also on how new technologies can be absorbed in market products and in final application scenario. So let's say that I was somehow looking for a different approach, more inclusive. So not only the classical top-down approach, which is followed when new systems and new applications are architected, but also a bottom-up approach from the technology point of view. So having a very focused vision on what the technology is, trying to understand how this technology can enable new application. So let's say that this book is somehow a generalization of this approach that I follow for RF MEMS, brought on a much wider area of devices, always falling in the MEMS and NEMS technology, so always relying on micro and nano systems, but not only limited to the RF field, so the field of telecommunications and radio systems, but also opening to the wide area of sensors, actuators, transducers, and so on. So this was basically the main idea driving me in developing this vision.
Following that, how will the transition to micro and nanotechnologies, as you discuss in your book, impact telecommunication infrastructure in terms of complexity and innovation?
Okay, this is a very good question because from my point of view, this impact will be twofold. We can, let's say, name it as incremental and disruptive, as many times happens when dealing with new technologies. So incremental means that these technologies will keep on improving KPI, key performance indicators and characteristics which are already under development to date. Like, for example, the increase of miniaturizations of systems, much pronounced integration of complex devices, and of course, all these somehow conjugated with the decrease of production costs, which is in any case critical for applications, and also managing an increasing complexity of systems, both at the core and at the edge of the network. In this incrementing development, I will also include the aspect of energy availability at the tiny ramifications of the network in order to ensure the proper operation. Then there is another aspect which is more disruptive, and this is probably the most interesting part, because these technologies can, in fact, enable unprecedented functions. So they can actually be the trigger to start new functionalities which were not, let's say, planned before. And this can be triggered by the technology itself. So this brings me also to the answer to the previous question. So this is why it is also important to have technology vision, so a bottom-up vision in which technology can be pushed into a certain application domain and probably enable new functionalities which were not, let's say, scheduled in the beginning.
Seeing the transition of these nanotechnologies, can you elaborate on the role of micro and nano devices in the 6G evolution as detailed in your book and the new capabilities they might introduce?
Okay, to address this question, I start from, let's say, mentioning one new acronym, which is defined and discussed in the book. This acronym is SILCI, which stands for System in a Low Complexity Hardware Item. So most of disruption and of innovation that micro and nanotechnologies can bring in the 6G scenarios, but more in general in the future network scenario, is that of integrating functions which are orthogonal among themselves and are typically addressed by more complex subsystems. So from entities which rely on software and hardware part, which have intelligence, which have computational capacity, and so on. What can be done with micro nanotechnologies is actually to integrate part of these functionalities within a unique hardware component, so within a unique sensor, which is then able to realize more than just sensing a certain physical magnitude and to transduce this magnitude into an electrical signal. Just to give you a very brief list of devices, which in any case are covered and discussed in the book. Micro nanotechnology already today, so without having this comprehensive vision, but just let's say following the technology development, already today were demonstrated in the scientific literature for devices like self-powered sensors, so very tiny sensors which are able to also to harvest proper energy from the environment to ensure their functioning. Or self-computing sensors, so sensors which are able also to implement some sort of treatment of the electric signal, like converting from the analog to the digital domain without the need of electronics, of ad hoc systems, and so on. And also very interestingly, self-healing devices, so micro and nanomaterials which are able to restore their mechanical properties when they undergo some sort of damage.
As per your book, how will AI transform network infrastructure to achieve resilience and self-sustainability in future networks?
Okay, so this is another very interesting chapter because artificial intelligence is actually object of a discussion in every in every situation today, from the technical community, but also in the general public, who is very excited, but also probably concerned about what AI can trigger in the future. So let's say that if we look at what is ongoing, artificial intelligence is already a crucial part of many services that we are day by day using on the internet, on our smartphone, on many of the apps that we are used to. So let's say the trend of exploitation of artificial intelligence on the service plane is already established and is developing very quickly. What is somehow unprecedented, and what is also in this case a disruptive aspect, is the exploitation of artificial intelligence on the so-called network operation plane. So not only in the services that we are day by day using, but also in how the network itself on the internal part, so for what concerns operation, is managed. This means to unleash a very pronounced flexibility of how the network can operate, starting from the core, so from what is usually referred to as the cloud, till reaching the very tiny ramification at the edge. Just to mention one interesting aspect of these AI boosted functionalities, a concept that is somehow growing the last year is that of self-sustaining network. So with 5G, we have been used to the concept of self-organizing network, so of partially softwareized part of the network, which are very flexible, which can be reconfigured very easily. Also, the network slicing is something which is turning very common with 5G. With 6G, the farthest step that will be taken is that of having self-sustaining networks. So portion of the networks, of the physical infrastructure, which are able to self-react to some limiting conditions and able to gather the resources that are necessary to their operation in terms of energy, in terms of bandwidth, and so on. This, of course, can be triggered by artificial intelligence, but this also has many implications at hardware level. So this is also, let's say, the context in which this book somehow tries to provide a contribution.
Dr. Jacopo, why, according to your book, is edge intelligence crucial for 6G and future networks? And how might it change our interaction with network infrastructure?
Okay, so first thing first, edge intelligence, which is also another very common buzzword today, is nothing more than artificial intelligence brought to the very edge of the network. So implemented in the very ramificated physical devices which we are used to day by day, like wearable devices, if we talk about end user stuff, but also remote sensing nodes and whatever is scattered, let's say, at the periphery of the network. This is quite a complex question which can be addressed in many ways, in many different ways. What I want to focus on is the amount of data transferred on the network. So if we think of the prediction of the data volumes, which are, let's say, day by day and year by year, actually traveling on the network, we will step from a number, which is also referenced and mentioned in the book, which is 64 zettabyte in 2020 of entire volume of data, which will rise up to 170 zettabyte in 2025. So just to have an idea, 1 zettabyte is 1 billion terabytes. So we can have a clear picture of the massive amount of data that will be traveling on the network. This is in conjunction with a strategy which was pursued by years, let's say starting from the first generations of mobile communication up to 5G, which is the trend to centralization. Centralization means that if we think a very practical example, if you think of our smart speakers that we are very used to in our daily life, when we our voice asking something to do some operation to the smart speaker, what they do is to record our voice, to transmit over the network our voice somewhere towards the core where we have proper artificial intelligence and algorithm which can understand what we ask to our device. And then, let's say, when what has to be done is identified by this algorithm, this information is sent back to the smart speaker. So this means transferring data back and forth over the network in order to proper operate this device. Of course, if we think of this huge volume of data, this purely centralized approach cannot be pursued anymore from many points of view, because the amount of data will be too large, because also this will be not sustainable from the environmental point of view, not only from the point of view of energy which is needed to transfer all those data, but also from the point of view of carbon footprint and sustainability of technologies in view of saving the environment. So what edge intelligence is actually a perfect tool to complement this centralized approach with a more distributed approach. So edge intelligence will mean bringing intelligence to the edge in such a way that many functions that today need the whole networks, portion of the whole network, it will be possible to implement them locally and have more efficient, faster response, also more reliable, because now we are very linked to the availability of a coverage. Imagine what can happen if we, for some reason, don't have any more coverage and our smart device is not anymore so smart because it's not able anymore to communicate with some servers, with some other portion of the networks where actually what it has to do is decided, is identified and decided. So to conclude, this will bring also to the further evolution of the Internet of Things paradigm, which will be the so-called tactile internet. So tactile in the sense that we will have functionalities which have such a low latency, so they are so fast in responding that are similar to the sense of touch. This is the reason why it is called tactile internet, or also the so-called Internet of Everything, where actually the idea of the thing, like in the IoT, in the Internet of Things, will be somehow overcome because we will start to use services without anymore the perception of the physical device which is delivering those services, like it is today with the smartphone or with the smartwatch or whatever. So we will go also beyond the physical perception of the devices which are implementing some functions. And this will be done also thanks to the edge intelligence.
This will take us to our final question. What key takeaway do you want readers to have from your book, particularly regarding how its concept might change telecommunication?
So, okay, this is probably the most complex question because closes all the all the discussion and all the motivation which is behind this book. So, starting from a very general point of view, I would like somehow to stimulate a different approach in thinking to future hardware software systems, thinking a bit out of the box in terms of new paradigms which may emerge in the future, and also going beyond the very consolidated co-design approach, because hardware software mutual optimization is what actually drove telecommunications, but more in general electronics since their evolution. So since probably more than half a century, probably something around 60 years, 6 decades. So for sure, in order to properly face the challenges that we have ahead, it will be necessary to complement these approaches, which are very effective and were incredibly effective up to now. But it will be necessary to complement them with something different, with some unprecedented. So my idea, my goal would be actually to let's say spark some curiosity in the readers, regardless if they are in the micro and nano system field, in thinking differently to future application, future devices, and so on. And then, of course, this also includes coming back to telecommunication and to how the telecommunication standards will evolve. I also would like to bring the idea of a more inclusive approach also from the point of view of knowledge and know-how necessary to develop these new, very attractive paradigm shifts. Because I just want to mention one emerging field of research which is very fascinating for me. It's called affective computing, and is all concerned to the fact of including human feelings and human emotion in the network application that will be developed in the future. If we think of how we experience these last probably 10, 15 years of evolution of the internet, and also of services on the move with social networks, with all these apps, these all different and orthogonal ways to communicate to each other. They are very nice, but they somehow are getting us used to being more and more physically distant, like now me and you are talking over this let's say remote conferencing tool. This is somehow cutting out all that part of human communication which is not directly linked to the word, but is more a non-verbal communication, body language, and so on. So affective computing is somehow a new research field which wants to embody all these features and enrich the way we can communicate also at a distance with all these very nice part which belongs to human beings, is not of other creatures and not of machines. So this is, let's say, also something which is somehow deviating by the scopes of this book, but not that much, because affective computing, of course, will imply a lot of sensing and smart sensing functionality. So this somehow brings back to the micro and nano system world.
Thank you, Dr. Jacopo. And that's conclude our discussion for today. Again, a heartfelt thank you to Dr. Jacopo Iannacci for sharing his expertise with us. To all our listeners, thank you for joining us, and goodbye.
Goodbye.